My name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. Welcome to part 2 of the series on RFID and IO-Link. In this video, I'm going to be hooking up an RFID head to an IO-Link master. I'll discuss what cable is needed to do so. Also, I'll discuss the coding and the pinning of that cable. I'll also review the LEDs of the RFID head, and finally show you the home tab of the web interface. Alright, so let's get started. I'm going to be hooking up the F61 RFID head seen here in the middle. The two other high frequency housing types are also shown, the 18GM and the flat pack. So first, if you've ever been in the field, you've likely seen the inside of a control box. Maybe the PLC, seen here on the left, is in there with a large amount of wires connected to it. Those wires going out to sensors like my RFID head. You may ask, doesn't all of this wiring take a lot of time, money, and materials to wire up? And with so many connections, aren't there more chances for errors? Yes. IO-Link is a low-level networking solution that helps us solve these problems. So real quick, an example of how to use IO-Link. I can place an IO-Link master out onto the factory floor next to an application, and then connect some sensors and actuators to it. Going this route means I don't need to run all the wires from each sensor back to the PLC in the control box. This greatly reduces wiring. And when I hook up a sensor or actuator to my IO-Link master, I'm only using one cable to do so. So easy. Now these 3 or 5 conductor, unshielded cables with an M12 connection are common, easy to work with, and relatively cheap. And when used with IO-Link devices, can be up to 20 meters long. Since shielding is not necessary, there's no specific guidelines which need to be followed when laying the cables. In general, this connection style is known as point-to-point. 2 devices connected to one another. This ensures fast, bidirectional communication and makes replacement of devices quick and easy. Remember, it's easier to connect a cable than it is to wire. So here's a nice picture which shows an IO-Link master set up next to an application. This is an ICE1 IO-Link master. It actually provides A ports and B ports, and I'll talk about those in a moment. You can see that cables are easily run to the sensors, and there's a couple cables to run back to the PLC which provide power and communication. This setup is super clean, versatile, and because it's IO-Link, an operator has access to a lot of real-time data regarding the health and current status of this application. For example, if a sensor is having issues, an operator located remotely could be notified and make sure the issue is fixed before a larger problem occurs. So first, these cables which connect our IO-Link masters to our actuators and sensors, like my RFID head, are A-coded, and you can see the picture here on the left. It notes that anywhere from 3 to 5 pins are used, each pin having a specific function. Here is a closer look at A coding. We'll connect a cable from here out to our RFID IO-Link head. Now, how many pins your IO-Link device will use often comes down to how much power is needed and whether or not the manufacturer wants to provide some additional functionality to their IO-Link device. So, how much power do we need? Well, an RFID head doesn't need much power, so the 200 milliamps, which A ports provide, are more than enough. The ICE2 IO-Link master that I'm using uses only A ports, and it has 8 of them. You can see those 8 IO-Link A ports shown here. This is from the datasheet. The 200 milliamps which the A port provides is usually enough for most applications. Now here's a question. If I hook up 8 RFID read heads, or 8 different devices to my IO-Link master, will they communicate just as fast if less were hooked up? The answer is yes, they will communicate just as fast. This is because each port has a separate IO-Link chip. Some IO-Link masters have B ports, as we saw in the previous slide, and these are great if you need an additional supply voltage. You'll need more power if running something like a valve actuator. In that case, all 5 pins of the cable would be needed, because the additional supply voltage will be connected via pins 2 and 5. Speaking of pins, let's discuss these a little bit further. Again, my RFID head doesn't need an additional supply voltage, so it only requires the use of pins 1, 3, and 4. And this can be confirmed in the RFID head's datasheet or manual. As seen here, you see that only pins 1, 3, and 4 are used, while the 2-pin is not connected. As a side note, if you have a 3-pin cable, that cable is only using pins 1, 3, and 4. You might think that a 3-pin cable would use pins 1, 2, and 3, but that's not the case. So again, we're seeing that pins 1, 3, and 4 not only provide power to the IO-Link device, but thanks to pin 4, the device can be either configured for an IO-Link signal or a standard digital in or digital out signal. An IO-Link signal carries lots of data, and it does this by going up and down very quick at specific lengths. It's kind of like a really fast Morse code. And when set up as a standard input-output device, the signal is either up or down, on or off, high or low, whatever you want to call it. The RFID head is not this type of device. It requires that IO-Link signal to communicate that large amount of data that's provided. Just think about all the data that needs to be written or read from a tag. Now here's an example of an A port compared to a B port. So again, what if you're using a sensor where the manufacturer offers some additional functionality, such as an extra digital in or digital out signal? Well, you at least need to use a cable with 4 pins, because the 2-pin is where that additional functionality would be used. You can see that on the left-hand side, DI/DQ means this pin could be used as an extra digital in, digital out. Again, my RFID head doesn't utilize this pin. As we saw before, pin 2 is not connected. And of course, if you need an additional supply voltage, you'll need a 5-pin cable and a B port seen on the right. In this case, pins 2 and 5 can be used to hook up an additional galvanically isolated voltage supply. In general, a lot of IO-Link devices just use 3 pins. IO-Link allows plug and play, which means communication starts right when I plug the RFID head in. I can see this by noticing the LEDs. Here, the flashing green LED indicates that IO-Link communication is active, and the blue LED indicates a read-write attempt is currently being performed. If I place a tag in front of my RFID head, the yellow LED indicates a read attempt was successful. Again, I'll talk more about reading and more specifically writing to a tag in video 6. So for now, let's go take a look at the Home tab in the web interface. Here, we see this information is only about the ICE2 block. I can see the model number, the part number, and how long the block has been running. But again, since the RFID head is plug and play, we can immediately go see information relevant about it. And that's going to be the focus of the next video, where I'll start discussing the diagnostic and configuration tabs of this awesome web interface. Again, my name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. And as always, remember that Pepperl+Fuchs is a leader in industrial automation. So click the subscribe button below to see the new industry-leading products that we come out with. And if I did a good job on this video, please click that thumbs up button so others can find it more easily. Remember, if we don't tell YouTube what's important by giving it a thumbs up, we're going to keep seeing only those shocking and crazy videos, which can be fun, but they're not helping us to become the intelligent professionals that we aspire to be. Thanks, and I'll see you next time.